The following is a selected video from masterthecontent.com, where you will find an extensive video library of lectures for a variety of standardized admission tests. We offer over 600 hours of detailed video lectures for a multitude of standardized tests. Use our interactive in-lecture table of contents to find specific topics of interest. Work through numerous in-lecture examples to help you internalize concepts. To learn more, visit masterthecontent.com. Your career, our passion.
Now we'll just briefly contrast the voltaic cell and the electrolytic cell, and then we'll get into what all of this is very shortly. Okay, firstly, let's talk a little bit about the voltaic cell. Well, as we just said, it's going to be a spontaneous reaction that's going to be producing electrical energy, right? And it does work on its surroundings. For example, here we're lighting this light bulb, right? Thus, we can say that the energy, right, is headed in that direction. Great. Now, if we talk about the electrolytic cell, right, with the electrolytic cell, it's a non-spontaneous reaction like we just said. And what ends up occurring in a non-spontaneous reaction, for more specifically what we have here, is we have a power supply that's now providing that electrical energy, right? And when it's providing that electrical energy, it's actually going to be doing work on the chemical system in our cell. And we can say then that our energy now is going to be going in that direction. Okay, great. Let's we'll delve a little bit deeper now, and we'll get into the components of a voltaic cell, and then we'll revisit in depth the electrolytic cell in a coming lecture of electrochemistry. Okay, great. We'll begin here with the redox reaction of zinc. If we see here, we see that the zinc solid, right, reacts with copper ions, right, to give us zinc ion and copper metal. And if we actually look at the reaction of that, we see that we have zinc metal, and it's being placed in copper sulfate. And when you do that, what ends up occurring is you're going to have copper that deposits on the zinc metal. And here is a picture of it actually taking place, where we have the zinc metal in copper sulfate, and then we have the copper being deposited. Wonderful. And the reason this occurs is because the copper ion actually comes out of the solution, right? Because of the electron transfer taking place here. And what ends up occurring is the zinc ion will actually come into the solution, right, as it loses its electrons, as we see here. And because of that, that's why we call this a reduction oxidation reaction. And now, if we recall, oxidation, right, is the loss of electrons. Let me just write that down, right? So we'll just say is a loss of electrons, and furthermore, your oxidation number will be increasing. And in reduction, you'll be gaining electrons, and your oxidation number will be decreasing. Excuse me. Okay, so if we see here, we see that the copper ion is actually going to be gaining the electrons, right? And it's going to be the zinc that's losing the electrons, right? We know that it's our zinc that's going to be getting oxidized, and it's going to be our copper that's going to get reduced. Thus, for our reaction up here that we see, let's go ahead and write the oxidation half reaction and the reduction half reaction. We'll begin here with the oxidation half reaction. And that's just going to be our zinc, right, giving us our zinc ion plus 2 electrons. Now, with the reduction half reaction, that's going to be our copper ion plus our 2 electrons, giving us copper solid. Wonderful. One other thing that we should be just do a quick reminder here is talk a little bit about this now. Oxidizing and reducing agents. Wonderful. Because our copper ion here is going to be gaining electrons, right? Then we can say that this is going to be oxidizing the zinc, right? So thus we could say then that our copper ion is the oxidizing agent. Similarly, we can say that the zinc, right, because it is losing the electrons and thus reducing our copper ion here, we can say that this is going to be our reducing agent. So just be comfortable with those terms. Should you need a review, just follow up on one of the preceding lectures. Okay, great. Now we're ready to proceed to our next slide. Now we'll talk a little bit about some of the components within the Voltaic cell. Okay. Cathode and the anode. Firstly, a cathode and the anode is an electrode. And what is an electrode? Well, it tells us here an electrode is an electric conductor through which an electric current enters or leaves the cell. Now, that's exactly what we see here, right? We have our anode and our cathode, our electrodes, where we have our electric current taking place as follows. Okay, great. So let's talk a little bit about the cathode first, then we'll talk a little bit about the anode. At the cathode, it's given a positive sign, right? Just as we see here, it's given a positive sign. And this is where reduction takes place. And as we see here, this is where reduction takes place. And the cations shift to the cathode. Thus, we see a cation shift taking place going to the cathode. This is a porous disk here. Okay, great. Additionally, this is where the electrons are taken up, and as we see, our electrons are being taken up here at the cathode. And we're going to do an extensive example of this in just a moment. Just want to first familiarize you with some of the actions that are going to be taking place in the Voltaic cell. Now, if we take a look at the anode, this is where it's given a negative sign, right? As we see here. Furthermore, this is where oxidation takes place. As we see, that's where oxidation takes place. Anions shift to the anode. We see the anions shifting towards our anode, right? And this is where electrons are generated. We see here our electrons are being generated at our anode. Okay, great. Now let's actually do an example.